This question was asked in UGC CSIR NET June 2011's paper. Let us see how one can solve this question. The value of the integration c dz z square e raised to z, where c is an open contour in the complex plane as shown in this figure. We have to find the value of this integral from these four options. In this figure, y-axis shows imaginary part and x-axis shows real part. We have to consider open contour right from -1 to +1. So here, function f of z is equal to z square e raised to z is an analytic function, and that is why closed integral CR plus C z square e raised to z dz is equal to 0. Here CR, it means contour, open contour for real part. Here we are considering only x-axis, and that is why y is equal to 0 and dy is equal to also 0. So here we are splitting this integral, closed integral, in two parts. So integration c z square e raised to z dz is equal to minus integration cr z square e raised to z dz is equal to minus integration from -1 to +1 x square e raised to x dx. Here we have considered z is equal to x, as we are considering only x axis. So, and this is the value of open contour of integral. And I is equal to integration from -1 to +1 x square e raised to x dx is equal to x square e raised to x -1 to +1 minus integration from -1 to +1 e raised to x 2x dx. By considering integration by part, or formula of this integration by part, you can solve this equation like this way. So we can have this equation that is I is equal to, in bracket, e raised to 1 minus e raised to -1 bracket close minus 2 into in squared bracket integration from -1 to +1 x e raised to x dx squared bracket close. So in bracket e raised to 1 minus e raised to -1 minus 2 in squared bracket, again integrating by part, x e raised to x from -1 to +1 minus integration from -1 to +1 e raised to x dx. So we can have this equation that is I is equal to, in bracket, e raised to 1 minus e raised to -1 minus 2 in bracket e raised to 1 plus e raised to -1 minus in square bracket e raised to x from -1 to +1. This bracket close with the big square bracket. So is equal to e raised to 1 minus e raised to -1 minus 2 e raised to 1 minus 2 e raised to -1 plus 2 e raised to 1 minus 2 e raised to -1. Here these two terms will be cancelled. So we can have I is equal to e minus 5 e raised to -1, which can be written like this way also, that is I is equal to e raised to -5 over e. First, integration c z square e z dz is equal to minus e plus 5 over e is equal to 5 over e minus e. So correct answer will be option C, that is 5 over e minus e.